Hello, let's continue our Sudoku adventure with Whispers by the Dozen by Strosahl. So, we do have normal 6 by 6 Sudoku rules, meaning in every row, every column, and every 2 by 3 box. We are placing the digits 1 to 6 exactly once each. We also have these green lines in the grid. Some are short, some are long. Adjacent digits along a green line have to have a difference of at least 3. So if this was, say, I don't know, a 3, the only digit this could be was a 6, because none of the other digits are 3 or bigger away from it. 5 minus 3 is 2. Only 6 minus 3 is 3. So if this digit was, say, I don't know, a 5, then this digit, let's use this digit. This digit is adjacent to it, so it has to be at least 3 different. So it could be a 1 or it could be a 2, but any other digit would be too close. And that's it. Those are the rules. There is a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. Okay, so one thing, there's 2 things that are probably going to be important in this puzzle, given that it's only German whispers. The first thing about German whispers is they always alternate low, high, low, high, low, high. I say low is a 1, 2, 3 number, and high is a 4, 5, 6 number. So let's say this digit happened to be 1, 2, or 3, a low digit. Then this digit here, we could not subtract 3 or more from 1, 2, or 3. That would put us in 0 and less. So we have to add at least 3 to 1, 2, or 3. When we do so, we don't stay in the 1, 2, 3 range. We cannot go between 1 and 3 or 2 and 3 or 1 and 2. So we're going to be jumping all the way to the 4, 5, 6 range. 1 could go to 4. So 4 is the smallest we could do with the minimum jump. But now that we're in the 4, 5, 6 range, we have the opposite problem. We can't add 3 or more, so we have to subtract 3 or more, and that brings us back to the 1, 2, 3 range. So we're always going to alternate, but right now we don't know which is which, but we do know they alternate. The other thing that we know is that 3 and 4 are very special digits, because if I try to put a 3 here, for example, 3 and 4 are digits that only have one pairing. So the 3 can only go as 6, as I explained in the rules earlier. Can't go with any other digit. And so it can't actually go in the middle of lines where both of its ends can't repeat, right? Because I'd have to put 2 6s here, and that's not allowed. A 4, I'd have to put 2 1s here, and that's not allowed. So we need to be careful about where 3s and 4s can go. So those are kind of the 2 properties of German whispers that I think are going to be useful immediately. Let's start by coloring this here. I'm going to use green and purple here, and we'll just alternate colors. We don't know whether green is low or purple is low, but what we do know is one's low and one's high. And so, like, we know that there's a low high here. Let's see, this doesn't immediately help. Now, I want to think about 3s and 4s in this box. So, what cells can be 3 or 4? This cell can't, because it's surrounded by 2 that can't repeat. Same with this one, same with this one, same with this one. So these are the only 2 cells that can be 3, 4. So this is a 3, 4 pair. And because it's a 3, 4 pair, 3 is low and 4 is high. So this has to be purple. And that lets us spread this coloring all the way around. We still don't know which is low and which is high, but we know these are different. And we also know that this is going to be 1 or 6, and this is going to be 1 or 6. Let's ignore this red for a second, because one of them will be 3, which has to be next to 6, and one of them will be 4, which has to be next to 1. But now this given 1 is coming into play, telling us that this can't be 1. So this must be 6. Remember, the 6 has to... It's not that 6 must be next to 3, it's that 3 must be next to 6. We can't make this a 4 anymore. So that's 3, that's 4, that's 1. And now we know what the lows and highs are. I prefer to use blue. Once I know what it is, I prefer to use blue for low and orange for high, kind of like temperature colors. And so now we know these are blue as well. And so now this is just 2 and 5 to finish the row. We know this had to be low, high. 5 has to be next to 1 or 2. It can't be next to 3. That's too close. And the 2 is gone. So that's our 1. Now this is just our 4 at the other end of here. And actually, we probably could have said that 3, 4 pair had to be here as well, but it kind of resolved itself without needing that. So 3 goes next to 6. This is our 5. This is a 2. And this all just resolved. Very nice. So where do we go from here is kind of the next question. Of course, that's always the question we want to ask. But this row is interesting to me because I know how they group up, right? Let's think about the 3 first. Whichever one ends up a 3, I'll just type it out. Whichever one ends up a 3, we don't know if it's this one, but whichever one ends up a 3 will be next to the 6, right? And now, whichever one ends up the 2, could be in any order. It could be over here. It does. Oh, this one would end up 2 in this case. But whatever ends up the 2, it can't be next to 6. So the only other digit it can be next to is 5. It can't be next to 4. And so then 1 and 4 end up together. You can also work backwards. The 4 has to be with the 1. And you can still work. You can do the 5 has to be the 2, and the 6 has to be the 3. So we're going to end up with a 3, 6, 1, 4, 2, 5, and 3, 6. So 1 isn't in any of these cells, and it's not here. So one of these is 1, meaning one of these 2 is a 4. Now the 2 is going to end up in one of these 2 cells because of Sudoku, right? Same with these ones. And so 2 is going to be next to a 5. You know what? I'm going to write this out with center marks. So 1 is going to be next to, let's get rid of these corner marks here. 1 is going to be next to 6 for sure. Wait, did I say 6? No, 4 for sure. And then we're going to have 2 next to 5. The 2s will end up here. So the 5s end up here. And then 3 is going to be next to 6. So either of these could be 3. So this could be a 3, 6. These cannot be 3 or 6. So these could be 3, 6. Okay. So that's kind of the penciling we have right now. I'm not sure I can do more with that right now. So we got to think about this row is the same, but it has the additional property. Well, first of all, it doesn't have this 1, 2 looking at the whole box, but also it's got these extra legs. But we can still think of this row as the same because these adjacent ones still have to be following the German Whisper rules. So let's think about our 1, 4 pairs. So this can't actually be 4, right? Because then these would both be 1. There's a lot of reasons that's not possible. So this can't be the 4, 1. And and over here, this can't be the 4, 1. Because this can't be a 4, and if this is the 4, then we'd have double 1. So this has to be the 1, 4, and this 1 tells us the order. That's 4 and that's 1. 4 is big, 1 is small. All right. Now, that does resolve 2. Oops, it does resolve gray. 2 and 5 there. So, and then we found that this now has to be 3, 6, so this has to be the 1, 4. Nice. All right, so 1s are blue. 5 and, sorry, those are small, these are large. So I need a 3, 6 pair here. Don't know the order. And I need a 4, 5 pair here. Those are both large. And we can resolve them. All right, so now I need a 2, 5 here or a 2, 5 here. So this would be 5, 2. And then what would go next to 2? Because we wouldn't have the 5 anymore. So it'd have to be the 6. So if it was 2, 5 here, that's how that would resolve. If it was 2, 5 here, actually it can't be. There's no 5s. This is a 5. Okay, well that resolves it. This is 5, 2, and 6. That's blue. These are orange. This is orange. Let's see how much coloring we can get done. I don't want to accidentally finish the puzzle before the coloring's done. We do get a 3 in the corner doing. That's nice. So let's finish this coloring. We know these two are different. So this uses up the last orange in the box. It uses up the 6, in fact. And so these both have to be blue. That's actually just true for the row as well. Do I know the order of these two? Not yet. I think I have to get some digits. So we have the 3 here, and we have the 4 here. We know there's a 6 in here somewhere. The 6, actually, this is just a pair. This is a 3, 6 pair. Ah, so this is normally what would be called a deadly pattern. Uniqueness, normally like in a regular Sudoku, would tell us that this can't happen and have a unique solution, because these could resolve as 3 or 6. But this little extra line here is going to tell us that this can't be 3 because this is small. So this has to be large and this has to be small. And so 3 is not large. So this has to be 6, 3, and this has to be 6, 3. That makes this large and this small. And so now these two are the 2 and the 1, and we're done. Both with the coloring and the digits. Very nice. All right. Really cool puzzle, Scott. I enjoyed how that flowed. How we could resolve the coloring on these, and then how this row and this row kind of acted. I like the demonstration on how this forces the 1, 4, 2, 5, and 3, 6 to be together, just by the nature of having those dominoes in the row. So I really enjoyed that. Hope you did as well. And if you did, why not leave a like, subscribe, and a kind comment below.